4-4, we're going to see a lot of repeats of things we've already done, which is fine. We're just kind of grabbing what we've already done, taking it a little bit further each day here. So the first one, it says sine is less than 0 and tangent is greater than 0. Which quadrant does this angle lie? So we've already done something pretty similar to this. It's worded a little different, but it's the same idea. So if sine of an angle is less than 0, that's a fancy way to say that it's negative. And if tangent of an angle is positive or greater than 0, that's a fancy way to say it's positive. So it's back to that kind of that all students take calculus or CATS thing. So all students take calculus is one I kind of prefer because CATS is a little tricky to follow. So everything's positive in the first quadrant, sine's positive in the second, tangent's positive in the third, cosine's positive in the fourth. So in this case, we're looking for where sine is negative. So sine and everything's positive first. So sine is negative down here, where y values are negative. Tangent is positive in the third quadrant and the first. So in these two. So the overlap would be quadrant 3. So this one is in quadrant 3. In example 2, we're going to actually put a line on the unit circle that's going to kind of go through the circle. It's not really it makes a triangle, but there's more to it than just the triangle. So it says the terminal side of an angle lies in the line y equals negative 4x, and it's in the fourth quadrant. Quadrant's important here because every line that goes through the unit circle, if it goes to the origin, it's going to go through 2 quadrants at least, or, well, 2 quadrants exactly. And it says find the 6 trig functions of that angle. So here's a little sketch of it. So on the unit circle, negative 4x goes to the origin, looks like this. So if we tried to make an angle out of this, we could be doing either second or fourth, but it tells us it's in the fourth. So we want to set up our triangle this way. Now this is probably a good time to skip to the next slide and then come back. Next slide I'll talk about something called a reference angle. And again, this is something that's come up before. We've mentioned it, or I've mentioned it. And I'm just going to kind of reiterate it. So when you've got an obtuse angle, say 210 degrees, well that lands right here. If you think about what that looks like on the unit circle as far as where it would lie, let's just kind of sketch a quick unit circle on here. So that would lie here at the same point as if it was a 30-degree angle. So what we can do is just take the terminal side and go back to the x-axis, and that's how you get what we call a reference angle. The reference angle is always acute, but again, it's just from wherever you are back to the x-axis. Now notice I didn't say positive x-axis, I just said back to the x-axis, the closest way you can get there that makes it an acute angle. Because if you take the sine or cosine of 210, you get the same results if you took the sine of 30 here and just worried about your sines. In this case, x would be negative and y would be negative. So cosine would be negative, sine would be negative. So let me apply that reference angle idea to this. So if our line, if we start at the positive x-axis and went all the way around, that's a pretty big arc. It's more than 270 degrees for sure. So I can do a reference angle here. Just make an acute angle. The terminal side back to the x-axis. And let's see how this shapes up. So the still things we do know for sure. We know if this is line negative 4x, the slope would be down 4 over 1. So however you want to design that, over here is negative 4, this side's over 1. So positive 1, negative 4. And then to get the radius, now I said we're putting on the unit circle. The radius isn't going to be exactly 1 here, and that's okay because we're making a triangle out of this line. And that's just the easiest way to do it. We could make it fit on the unit circle. It's just that would make it harder. So we don't really need to do all that. So if I square this side, I get 16, square that side, I get 1, add them together. Take the square root, do Pythagorean theorem, you get square root of 17 right there. So let's find the 6 trig functions for that angle. And keep in mind, when you do the signs like this, you don't have to worry so much about where everything ends up. You don't have to worry about whether sine's negative here or tangent's negative here, things like that. So let's start with sine. Sine of the angle. All right, well, what's across from that is -4, and square root of 17 would be the hypotenuse. And we're going to rationalize. So -4 times the square root of 17 over 17. That's our sine value. Cosine, well, that's going to be adjacent over hypotenuse, so 1 over square root of 17. Also rationalize this one out. So square root of 17 over 17. Tangent, it's going to be the opposite over the adjacent, so -4 over 1, or just -4. All right, now back to the inverse of sine, so cosecant. Let's see if we can do this an easy way. If I just start with the beginning here and flip that, that'll be a lot easier. I can always take this and flip it, but then I got to rationalize again, it's just more to it. So negative, I'll just put a negative out there to say the fraction's negative. Square root of 17 on top, negative, or 4, just 4 on the bottom. And put the negative out front. We know that the whole thing's negative. All right, secant. Secant's going to be the opposite of cosine, so I'll just take that and flip it. Square root of 17, that's it. Got it. And then finally, cotangent. Cotangent would be the opposite of tangent. So tangent was -4 over 1, this will be 1 over -4.